Okay, so this is going to be a tour of my processor, which I was talking about a few days ago. So I'll show you how the thing works first of all, and then I'll show you a bit on how the process works. So first, let's add two numbers. That's what it does right now. That's a program that I've written for it. It can only add two one-digit numbers that give a one-digit number as a sum right now, but I'll be updating that sometime. So let's add 5 and 4 and let's start it. It's quite slow. Let me up the tick frequency up and 9. So yeah, 5 plus 4 is 9, and it just showed you that. And for the next one, I'll put the tick frequency a bit down. What the tick frequency is how fast the clock of this thing is working. So the faster the clock is, the faster the operations are performed. It's like the clock speed for your computer. It is the clock speed for your computer. So next, let's add 4 and 2. And let's start the simulation. This is a bit slower than last time. And you just saw how long that actually took. 4 plus 2 is 6, we know that. And it just did that. But it is quite slow. The next part, I'll go a lot slower. So I'll go at 8 Hertz, and while the process is actually happening, I'll tell you what's happening behind the back. So for this, let's add 3 and 2. And okay, so let's start. Okay, so what's going to happen is this 3 is going to be taken into the system, and that's going to go as its ASCII code. So I'll just go into the system here, and 33 is stored in memory right there. What the 33 is the ASCII code of the number 3. And now the next step is it processes this and then changes that into its the number 3, so that you can actually add stuff to it. You can't add stuff to 33 and hope that it'll give the right answer. Then it'll do the same thing for 2, as you just saw right there. And now it's going to add it, and then it's going to store the final result and then change that back into ASCII. So right there, as you can see, 35 came up and was stored there. That's the ASCII code for 5, and it just stopped. So if we go back, yes, the final result, it just gave the right answer. It gave 5. So that's what's going on behind the back. Okay, so I told you that you cannot add things which give a result which is greater than 9. So I'll just show you what happens when you do that. So let's add 9 and 8, and the result will probably be a letter, because the ASCII the ASCII code for the final answer would probably be that of a letter. So let's start, and let's just put the tick frequency up so we don't have to wait a long time. And start. There. It gave A as the answer. So now you know 9 plus 8 is A. And just in case you want to see how it would do at the highest possible frequency, let's add 4 and 2. We've already done that. Whatever. Let's start. Go. 6. That was slow. I hoped that the answer would come up instantly, but it didn't. So yeah. I guess I'll put up a more detailed review of what's happening a bit later, but not right now. As you can see, nothing is actually going on right now. It's just stopped. So I need to refresh the entire system for it to do anything useful. And yeah, so this is a program that's actually running. That's a code for the program rather in machine language. So I think this is quite cool. And yeah, that's it. Thanks.